Good morning, one and all present here. So today we are going to start with our unit 5 of our thing. So first, what are the things we have seen from the first 4 units? So first unit we'll see with respect to our all channel related data, right? So what are the types of channels are there? What are the characteristics, right? And what are the things happen with respect to a channel? There is interference. So all those things we have seen with respect to a channel in your first unit. Then second unit, all the parameters with respect to your cellular concept we have seen. So your Doppler spread, then your coherence time and all the cellular multiple access, your TDMA, CDMA, FDMA, all those things we have seen. Then in a third unit, all your digital modulation code, that is coding techniques, that is what are the encoding and digital signaling schemes we have seen. So with respect to the 5x4 DQPSK, OFDM, all your things relevant with our wireless communication, we have seen the third unit. So fourth unit, so avoid your ISA and fading. So what are things required at the receiver side and transmitter side? What are the components we can add? That is your equalizer and your diversity we have seen. So at the end of your unit 5, so we'll be focusing on the multiple antenna techniques. So from the name itself, we can guess what you infer from the term multiple antenna techniques. So you all people go through with your antenna techniques, right? So what are things, the parallelly we are seeing with your antenna and wave propagation, what are the types of antennas are there? So many antennas will be studying with respect to all applications, but here we are going to focus only with respect to our wireless communication, right? So what is the term multiple antenna technique? So here we are going to consider about more than one antenna. We are going to present both at the transmitting side as well as at the receiver side for our quality of that is to improve the quality of our transmission. So both at the transmitter and receiver side we are going to place more than one antenna, right? So that is why it is called as a multiple antenna technique. So first we'll see what are the topics present in your fifth unit, right? So first to be focusing on it, Mimo system. So what is mean by Mimo? Multiple input, multiple output system, right? So that is your first concept in your unit 5, MIMO, multiple input, multiple output. So what is the multiple input here and what is the multiple output? Multiple input is nothing but what is the end terminal of your communication in any transmitter is your antenna, right? So multiple antennas present at the transmitter side as well as multiple antennas present at the receiver side. So that term is called as MIMO technique, that is multiple input, multiple output system. So what are the basic block diagrams, types of MIMO system, what are the parameters we are going to concentrate with respect to MIMO system. So all these things are first focus on the MIMO, right? So the second thing is spatial multiplexing. So far we have studied so many multiplexing types. So what comes into the terms of spatial multiplexing, right? So first we want to know what is a multiplexing. Everybody know multiplexing is nothing but we are transmitting more than one signal through a single channel, right? That is called as a multiplexing. So now that we have focused on TDM, that is time division multiplexing, FDM, frequency division multiplexing. So now we are focusing on your spatial multiplexing. It's nothing but we are going to place more than one antenna at the different interval, that is a space. So now we are going to focus on the term space, that is we are placing at the different thing and we are going to transmit the signals to a single channel, right? That is called as a spatial multiplexing concept. So this is very important with respect to a MIMO system. Why means here we are going to place more than one antenna at the transmitter side and also at the receiver side. So how we are going to placing and we are transmitting, that concept lies under your spatial multiplexing, right? So then we are going to focus on system model. So how we are going to model the system with respect to a MIMO system, right? So in the MIMO, how we are framing a system structure, what are the mathematical equations relevant to that. All those things we are going to focus on the system model. Then we are going to see about pre-coding, beam forming, then transmitter diversity and receiver diversity. So pre-coding means before we are transmitting, we have to code the input what we are sending from the transmitter side to receiver side. Then at the receiver side, we are going to decode the same and we are going to retrieve the original information what we have transmitted. Right? Then the concept of beam forming. Then your transmitter diversity and receiver diversity. If you place more than one antenna and if you transmit the information at the transmitter side, then the diversity concept applies there. It's called as your transmitter diversity. Right? Already we came across your diversity concept in the fourth unit itself. There what we have studied all the different types of diversity, how we are going to maximize the diversity. So these are the concepts we have studied with respect to the fourth unit. Now what we are going to focus on means your transmitter and receiver diversity means more than one antenna. If it is present at the transmitter side, then the term is called as your transmitter diversity. The same happens at the receiver side. If more than one antenna we are going to use at the receiver side to receive your signal, then it is called as a receiver diversity. Right? Then an important term called CSI. Please note down it. CSI. So the abbreviation CSI, the expansion for that is channel state information. So this is a new thing introduced to you. CSI is nothing but channel state information. So from the name itself, we can guess what is the thing it is going to infer. It is nothing but it's going to inform what is the characteristics of the channel, what are the things maybe happens with respect to your channel. So if you know your channel at the transmitter side itself and also the receiver side itself, we may predict what may be the fading takes place. Based on that, we can able to send and receive the signal. And if you know the error which is going to happen in prediction itself, we can able to easily eliminate that one and we can able to extract your information what we have transmitted. So that is the main purpose of your channel state information, right? So in both transmitter diversity and receiver diversity, if you know this information and without knowing this, what is going to happen our diversity concept, what we are employing at this multiple antenna techniques, we are going to focus at the end of the unit, right? So that is the thing, channel state information. Then capacity in fading and non-fading channels. So capacity means what happens to our capacity of the channel with respect to the fading and non-fading techniques, right? So fading means we'll be having two types, right? What are the things means your flat fading, the selective fading. Then by knowing your CSI at the transmitter and receiver, we can proceed with the capacity. Similarly, without the knowledge of CSI at the transmitter, if you know the knowledge at the receiver, what happens? So all the four possible combinations we can discuss. Know the CSI both the transmitter and receiver. Know the CSI at only transmitter without the information of the receiver. And if the receiver knows your CSI, but transmitter doesn't know it, and both of the system, that is your transmitter as well as the receiver, doesn't know about the channel state information. So all these cases with respect to fading, that is fading and non-fading channel, what happens to your capacity? Here the capacity means the transmission, how far we can able to get the information. All those things we are going to, at the end of your fifth unit, we are going to focus on the advanced concept of a wireless communication. In future, what are the things? So far, we have stopped up to the 4G applications, right? So with respect to your 5G, what happens to your wireless communication? That is advanced technique. What are things developed and now they are testing or under developing under the 5G. That is your fifth generation communication. That is the end of your fifth unit, right? So out of which in this session, now we are going to focus on the basic concept of your fifth unit, that is Mimo, right? So as already I informed, the Mimo system stands for your multiple input, multiple output. So I'll just write this. You note down it. This is a very important thing. Multiple input, multiple output, right? So then it comprises, that is what are things present as the main thing we are focusing on your antenna element and then adaptive signal processing. So already you have heard the word adaptive in your equalizer technique itself. What is the meaning that is we are given for the adaptive? That is adapted to the current situation based on the expected output and actual output what we are getting, and based on the situation it has to minimize the error, that is called as the adaptiveness. Okay, so that is the thing you already came across like ADPCM, that is adaptive, your delta pulse code modulation, all the concept what we have seen. Adaptive is the word which is mainly given to the thing. We have to find out the error between your actual and expected, that is what is the output coming and what is our expected thing. We have to find the error and we have to minimize it. For that only the previous class what we have seen is here LMS algorithm and all. So repeated iterations will reduce the errors, and ultimate aim is to bring it to the next stage and the present stage to be equal, right? That is called as your rate of convergence. This is the parameter of your equalizers, right? So here the adaptive signal processing is, so we have to play, that is check the presence of your antenna positions and antenna technique. We have to receive all the signal, process it, that is the called as your adaptive signal processing, right? So the next point what we have to see is the multiple antennas at the transmitter side and multiple antennas at the receiver side we are going to use. Now we will see what is the basic block diagram we are going to see with respect to your MIMO system, right? Block diagram of Mimo. So before getting into the block diagram of Mimo, we want to see what are things present in the basic communication system. So in the transmitter side and at the receiver, in between your transmitter and receiver, we will be having your channel, right? So transmitting side, what are the things to be take place means your coding, modulation, then mapping. So what are the things we are doing at the transmitter side? The same reverse process to be performed at the receiver side to retrieve back your information. That is coding means we have to do the decoding or demapping. Then the inverse of your mapping is demapping, and modulation, what are the techniques we have performed? The reverse side, demodulation, we have to do it. So once we'll recollect what is the basic blocks present in it. So your coding, these are the techniques what we are going to do at the transmitter side. Coding, modulation, and then mapping. So we are going to take the input which has to be transmitted from the source to the destination. So these things are taken place at transmitter side, and then passed through the antenna, it is communicated. So the next block what present here is channel. So the channel may be wired or wireless, but in our thing we have to concentrate on the wireless channel. Then at the receiver side, the reverse operation. So this is the basic concept what we are studying. Before entering into the MIMO, first we are just revising what are the terms to be present. So coding means we have to do, that is from reverse only we used to be done it. So what is the stage 3 here is mapping. So demapping, demodulation, and then decoding. At last what we received is your output, which is nothing but what is the input we have transmitted at the transmitting side. So this is the basic of your communication. So our MIMO system will consist of the transmitter and receiver with multiple antennas, right? So at the transmitter end, we'll be having a coding and modulation, mapping is done, and at the receiver side, the reverse operation. So in your wireless MIMO communication systems, what are the main advantages we are having? Why we have to go for that? That you have to note down. Higher data rate and lower error rate. So higher data rate means what are the information we are transmitting, we will be getting at the receiver side with the same speed of operation. That is the first thing. Excuse me. The second thing is error rate. So whenever we are transmitting through the wireless channel, automatically fading, interference, noise, all those things comes into the concept of interest. So in spite of that, our error rate, if you measured in your MIMO, it will be reduced. Ultimately, what is the thing behind in your MIMO? We are going to transmit the same signal via the multiple antennas. Multiple antennas at the receiver side is going to receive it. out of which is having a good clarity and speed of transmission is high, that one we are going to take. So this is the concept behind that. Because of the concept, what is the advantage we are gaining is higher data rate and lower error rate. So we can write it as a advantages of MIMO, higher data rate and then lower error rate. So this you may consider on your 2 marks point of view. What is the advantages of your MIMO system, right? So now we can focus on your benefits of multiple antenna technique. So what are the benefits we may get by using this multiple antenna technique? So before going to the block diagram of the MIMO, so which is nothing but, so if you see that this is your transmitter and receiver, we will be having more than one antenna survey. This is indicates the n number of antennas. Same thing we will be having at the receiver side. So this may be your transmitting channel, right? So this is the basic block diagram of your MIMO concept. Now we are going to focus on what are the benefits, that is what may be your characteristics, what are the parameters we are going to concentrate on the multiple antenna techniques, right? So first block what I have drawn, the same thing, block diagram of MIMO is going to come here. Benefits of multiple antenna techniques. So as I mentioned, first block is going to be your MIMO, which is nothing but what is the basic block now I have drawn. So here TR indicates transmitter. So it is going to have more than one antenna. So this indicates your antenna. And similarly at the receiver side, more than one antenna I am going to draw for receiving it. So the triangle indicates your antenna at the transmitter side as well as the receiver, right? So here it is basically depends on your spatial multiplexing. So as introduction of this unit itself, I told you about what is the spatial multiplexing technique, right? So that is the major component here. Then spatial diversity. So first of all, you have to know about what is the difference between diversity and multiplexing. Multiplexing is we are going to combine everything and transmit it to the single channel, right? But in a diversity, we are going to place more than one antenna. All these information, same information of the multiple copies going to transmit. Each thing may have the different time of reception and also it will have the, that is the multipath will may have the different interference or fading effect, right? Out of which is having a high quality, we are going to take it. So it is called as your spatial diversity. So MIMO means you have to remember the word spatial diversity and spatial multiplexing, right? Major two concepts lies behind your MIMO. Then smart antenna. So where we'll go with the concept of smart antenna means your beam forming, right? Smart antenna where we concentrate this word is beam forming. These are the major things what we have to concentrate once we have entered into the MIMO. That is your spatial multiplexing technique, spatial diversity technique, smart antenna, beam forming. So beam forming, the concept behind that, what are the types with the block diagram, we'll see at the topic which comes on the after your system model, pre-coding and all, right? Then so if you take your MIMO system, the parameters what we are going to say is multiplexing gain. So we know what is multiplexing. So gain what we achieve using the multiplexing concept is termed as your multiplexing gain. And then due to diversity, what is the gain we are going to achieve is termed as your diversity gain. Then by using the concept of different types of antennas, what are the gain and interference we are going to get, that is termed as antenna gain interference, right? By utilization of your antenna, what is the gain we are going to achieve? What is the interference? That is the fading effect or noise which is going to contaminate by transmitting through that antenna. These are the parameters we have to consider. Multiplexing gain based on your multiplexing concept, diversity gain based on your diversity technique, and then antenna gain based on the smart antenna systems what we are going to employ with the respective MIMO system. Then there is actually a trade-off will take place between the achievement of these gains. What is mean by trade-off? If you achieve one thing, for that case, we have to lose the another one. The best example what we have gained is, so if you concentrate on the quality of the cloth, then we have to compromise with the cost of it. If you want a good quality of the cloth, automatically what we will do, we'll go with purchase with a high cost. So if I want more number of, that is quantity, I want 10 set of clothes for the same amount, then I have to compromise with the quality of the cloth. Both the things cannot be achieved at the same thing. So you can remember this example, quality and then quantity. Any one thing we can achieve at the rate of your cost, right? So this is the day by day time what the example we are using with respect to the clothes. If you concentrate on the quality of the cloth, then we have to compromise on the cost. So we have to go buy with the higher cost material. Similarly, if you want more number of quantity, 10 clothes I want for the same amount, then automatically the nature of the cloth what we purchase is reduced. Similarly, there is a trade-off take place between your multiplexing gain, diversity gain, and then your antenna gain. So if you achieve one thing, we have to compromise with respect to the other based on the application, and it also depends upon the user only has to decide which we have to bear. That is, with respect to the application, we have to concentrate on the which gain we require, that we have to give priority. Another thing we can go with the compromise, right? So if you go with the multiplexing gain, we can get the advantage of high bit rate. So what is mean by bit rate? Number of bits transmitted per second is called as your bit rate. So if you want the high quality of your bit rate, that can be achieved by using a multiplexing gain. Then diversity, if you go with that, you can achieve smaller error rate. So all the things we cannot achieve at the same time. One thing which is required for our applications, we have to get it, the compromise of the other, right? Then if you go with the antenna gain and interference, we can achieve both the things is also possible. High bit rate or else high bit rate or small error rate. So this can give any one thing as per our designer's choice, right? So always multiplexing gain will produce your high bit rate and diversity gain will result with the smaller error rate. Antenna gain, any of one thing as per the designer's choice we can get it. Either bit rate must be high or error rate will be lesser, right? So these are the benefits of your multiple antenna technique. Once again, just overview of it we can see. First block, what I have drawn is your basic MIMO block diagram. TR indicates your transmitter, RX indicates your receiver side with the multiple antennas, right? So that characteristics only we are seeing here. Basically, if you start with the MIMO, the three concepts we want to focus is spatial multiplexing. Spatial multiplexing is we are going to place more than one antenna, but from all that, what are the signals we are receiving? We are going to transmit to the single channel. Then spatial diversity. Diversity is nothing but the same concept what we have seen with respect to the fourth unit. More than one antenna, both are transmitter as well as the receiver side, which will be multipath propagation only, out of which having a good quality of the signal with reduced error and high speed of transmission will concentrate and take it. The third component what we are seeing is a smart antenna, and then with respect to that, what is the beam forming, right? So by applying a MIMO technique, what are the gains we can achieve? Is multiplexing gain, diversity gain, and then antenna gain. So multiplexing comes from your spatial multiplexing gain, and diversity comes to spatial diversity. By using of a smart antennas in the beam forming technique, will achieve your antenna gain. So using that, As already I mentioned, we'll be having a trade-off. At the same time, all the things cannot be achieved. One thing at the trade-off of the other, we can achieve it. So, multiplexing gain result with high bit rate, diversity gain result with small error rate, antenna gain interference result with either high bit rate or else small error rate. Okay. So, whenever if it is asked in the part B question, we have to concentrate. So, if what is the topic we have seen is a MIMO. First thing you have to know the abbreviation and expansion of it, and then the definition with the block diagram. Even if it is asked in the 2 mark question, write the explanation of your MIMO with this block diagram, right? So this block is very important. Even if it is asked in the 2 mark question, please explain the answer with that diagram. You can easily able to get the 2 mark question, right? Then we have to concentrate on the benefits of multiple antenna techniques. That is, what are the things present here? We can explain with this block diagram, right? So always a balance is struck between your power efficiency and spectral efficiency, right? Power efficiency and spectral efficiency. So MIMO, the main thing why we are going here is it's a cost effective also, right? So I'll draw one diagram by using your MIMO technique and without using your MIMO, what may be your signal quality. So from the diagram, you can able to understand what is happening inside your MIMO, right? So for example, MIMO can be used with Wi-Fi technology. What is the number for your Wi-Fi with respect to IEEE concept? MIMO can be used with Wi-Fi, which is nothing but your IEEE 802.11, right? So it is nothing but Wi-Fi means without wire, that is the wireless communication, we can able to connect more than one device. What is the data life example we are seeing for that Wi-Fi? So mobile phone, what we are using, right? Mobile data we can share. Either we can go with the in our mobile phone itself. If you switch on your hotspot, we can share our mobile data with the other users. Minimum we can choose how many users we can able to accept. From 1 to 10 users we can share the mobile data. Based on the number of users, automatically the data sharing may change. That is, the speed may get vary because of a number of devices connected to it. So the master device which is providing the mobile network should switch on your mobile data and also your personal hotspot. The slave devices, what all are going to get the mobile network, should switch on your Wi-Fi, and that particular device port, if you mention it, we can share the thing. That is your concept of a MIMO used with the Wi-Fi. So here with the MIMO technology, so if you see that a digital notebook we are using, right? PC, a digital notebook, on this side wireless access point. So this is a service provider here. So it is going to have your antenna things. So with MIMO technology, if you see the connectivity between the device will be more. This indicates there is a small arc I am drawing, right? This indicates the connectivity established between your service provider is nothing but wireless access point and your notebook, that is a digital notebook, what that is going to get the service from it. But without MIMO technology, if you see the same thing, your notebook, digital notebook, what we are using in our day-to-day life, this is your wireless access point. Wireless access point. So the connectivity established between this get reduced, right? With MIMO and without MIMO. So this is the best example you can explain with and without MIMO what happens between the device and service provider connectivity concept, right? Then we are going to concentrate upon what are the types of Mimo technique. So from the name itself, we know Mimo is a multiple input, multiple output. Again, it is divided into four types. Types of Mimo. So first type SISO, single input, single output, right? Then second one, single input, multiple output. Third type is multiple input, single output. And the fourth one is multiple input, multiple output. These are the types of your MIMO technique. So just I'll draw the diagrams. MIMO with SIMO, transmitter, and then a single receiver will be present, right? Then MIMO with this is single input, single output. This is single input with multiple output. So transmitter will have only one antenna, but at the same time, receiver you will be having more than one antenna. What the things I have drawn is here? Signal transmission, then third type of classification, MIMO with MISO. So multiple input, single output. So transmitter will have more than one antenna, but at the receiver side, we will be having only one antenna. That is the multiple input and single output device. The last one is what we have told now, that is MIMO with MIMO concept itself, transmitter with more than one antenna, both at receiver as well as transmitter. So here, if you see the establishment of connection in this method, the antenna number 1 is connected to all the receiver antennas, which is nothing but 1, 2 up to n. Similarly, 2 is connected to 1, 2 and all the n antennas. Similarly, nth antenna is also connected to 1, 2 and n. So that is the basic connection establishment between your single, that is multiple antennas at the transmitter as well as multiple antennas at the receiver side. So once again, I just call out what are the types of MIMO. Single input, single output, single input, multiple output. So single input means one antenna both sides. Here, one antenna at the transmitter, more than one at the receiver. Multiple input and single output, more than one antenna at the transmitter and one antenna at the receiver side. Here is the basic MIMO concept. N number of antennas connected with all the n number of antennas at the receiver side. This is the connectivity establishment, right? So this is the basic introduction about our unit 5. What is the MIMO concept? What are the definition, basic block diagram? Then your MIMO one example and the block diagram what we have seen. Then another concept what we have seen is the parameters. What are the major concepts involved with respect to the MIMO, and then types of MIMO, right? So one more question now I will discuss, that you can post it as an assignment. Right, so the basic introduction about what is the thing now we have seen with respect to a MIMO concept. The relevant 1 mark, just we can see now. So you can use this one for your assignment. You can post it in our Google Classroom, right? We can share with that your answers. So first question, I think I can erase everything from the board, right? Relevant to that. Good. So First subjective type question. Mimo stands for, you can just go through our lectures. In that itself, I have given the answer for this first subjective. What is the Mimo, right? Second question. In Mimo, which factor? In Mimo, which factor has the greatest influence? Greatest influence on the data rate. So we have seen so many parameters with respect to our Mimo, out of which is having a high relevant to the data rate. You have to choose. For this one, I'll give the option: size of antenna, size of antenna, height of antenna, number of transmit antenna, that is how many antennas we are using for that, right? Number of transmit antenna, area of receive antenna, area of receive antenna. I just recall it, which factor is having the high data rate, that is the thing we are going to use. So size of antenna, height of antenna, number of transmit antenna and area of the receive antenna. So just go through it, then find out which is the best option, right? And this is a general question. Mimo was developed in the year. That is the latest concept which was established in which year? So I can find out the answer from the surfing it in the Google, right? Mimo was initially developed in the year. I just give it as a filler. Just find out what is the answer for the establishment, right? Then one more question. Mimo is a smart antenna technology. Find out whether it is true or false. Mimo is a smart antenna technology. Find out which is true or else false, right? All these things are basic questions. So just what are the topics we have seen today? With relevant to that, I have posted the 4 questions. So just go through it and give the answer through your Google Classroom, right? Thank you.